Okay, so we've been talking about chi-squared all week. Definitely a topic that is worth taking that amount of time because there's just so much to talk about when we get there. Did anybody have any specific questions? Did you want me to do like a recap or do a recap? Okay. So this is where we started on Monday. Now the data you collect is what's called the observed frequency data, and we place it in a 2 by 2 contingency table, or this one's a 2 by 2, but you place it in a contingency table where the column totals and the row totals should give you the grand total of everything in your survey. All right. Now, associated with the observed frequency values are going to be the expected frequency values. And how do we find those? Okay, Spencer. Okay, the column sum times the row sum divided by the grand sum. We do that for each of those cells there. Perfect. Okay. Everybody seems to be doing okay on that. Here is your formula. Okay, that's sigma, capital sigma. We want to take the summation of the squared differences between the observed data and the expected, and then divide that by the expected values. Okay, and we had an idea early in the week that if a small value of my calculated squared was given, that they were going to be independent. A larger value, they would not be independent. And we worked through a few examples, but then we started to see, okay, at what point do we go ahead and say it's gone from independent to not independent? And that's where we have the critical value. Okay, and there are two things that help me determine what the critical value is going to be. The first one is degrees of freedom. What is that? Okay, Kayla?
Yeah, sorry. Brain fart is like the thing.
The
Yeah,
things.
the
Okay.
those
What's that again?
like how far they're allowed to be different. The actual thingy. I'm trying not to
Okay.
the definition.
The thing. It's like how far they're allowed to be different
From the
than
actual
the
number.
critical value, right?
Okay.
Now the degrees of freedom?
I don't really know.
No.
I thought this
Now, the degrees of freedom, okay, the degrees of freedom refer to your table itself. So how many values you are able to input freely within reason of the totals that we have before the table itself starts to take over. Like in this case here, we always calculate that by taking the number of rows minus 1 times the number of columns minus 1. So a 2 by 2 table will have a degree of freedom of 1. That means these 4 cells right here, now I can input a value into any of those 4 that I want, again within reason for the totals. But once I do that, because of the totals, the others, the table's kind of going to take over itself. I don't have the choice anymore of what they're going to be. We also looked at one that was a 3 by 3, and I believe I had you guys just choose random numbers. Okay, so if it was a 3 by 3, the degree of freedom was going to be 4. So out of the 9 cells, I can only plug in whatever values I want to 4 of them, again within reason, before the rest of it starts to take over. Like here, even if I were to go ahead and just remove 2 random numbers, okay, yeah, I can't just go ahead and start plugging in whatever numbers I want for the rest of them. Like for example, yes, they have to match up the row totals and the column totals. Okay, so that's what we're talking about when we say degrees of freedom. Okay, and what was the other one? The significance level. And we had 3 of those: 1%, 5%, and 10%. And typically I like to go 5%. For me, that's just kind of middle of the road. It's not too strict, and give yourself just a little bit of leniency as well. If you go with 10%, you're allowing yourself more leniency to hopefully get the outcome that you're wanting. If you're wanting something much more specific, you'll go 1%. But once you have, okay, both of those together, the degrees of freedom, and we know what your significance level is, then this chart right here is how you're going to go ahead and get your critical value. Now, a lot of times, like I said, on those paper exams, they're not going to provide the table. They'll just go ahead and give you the critical value. Yes?
How much, how do you know which significance level to use?
It's really up to you, whatever you think is best. I mean, there's no right or wrong reason for choosing one or the other. I think it really just goes back to specificity. Like how accurate do you want your results to be?
Really accurate. You choose like 1%.
You choose 1%. Okay. And you want to give yourself a little more leeway because let's say maybe 1% showed that your quantities were not associated. There was no relationship, but maybe at a 5 or 10 it does. Okay. And you could definitely do that. Okay, so it's really just your choice. But a lot of times, like I said, on the paper exams, they'll go ahead and say, okay, here's the significance level we want. Here's the critical value. What's your calculated value, and would it be independent or no? Okay. All right, so like here, let's say we were working with a really large contingency table. We got DF, degrees of freedom of 8, and let's say we were going to go ahead and be very specific. We wanted 1%. What would be my critical value? 20.09. And the way we've been talking about this, do we want our calculated value to be larger than or smaller than?
Smaller than, larger than.
Yes, but remember, independent means there's no relationship.
Oh,
So we're hoping to have it greater than. That's the case we want. We want the value we determine to be larger than the critical. Okay, if it's larger than the critical, we know that there's something going on there. We just may not know what. Emily? Yes. So the critical comes from the two items, your DF, the degrees of freedom, and the significance level. Okay, and Spencer?
If you're trying to prove that they are independent, so if you're doing that, wouldn't you want it to be smaller than the critical?
Yes, if you're trying to show that there is no relationship, then I would probably go with 1%. I'd try to go as specific as possible. And if that one shows you that there is a relationship, I mean, yeah, there's got to be something going on there. In one way, and somehow, some way, one influences the other or has some kind of effect on. Okay. All right. And then what's this p-value that we brought up? It's pretty much that's it. I think of it as a confirmation. But it's reversed from what we do here. While we want our calculated value to be greater than the critical, okay, we want our p-value to be less than so that we reject the null hypothesis. Remember, the null hypothesis always states that they are independent. The alternative hypothesis says that they are not independent. Okay? And you'll always compare the p-value to your significance level. So it's only going to be against 0.01, 0.05, or 0.1. Okay, the 1, 5, and 10% that we had there. Okay? So like I said, a lot of information, and we took, quite a bit of time going over it, which is good. So let's go back to a previous problem. Okay. Maybe one. I thought there was another one that we did. Okay, this one here about the exercise and no regular exercise. Okay. We can go ahead and plug this in and see what we get. Okay, because I remember, didn't we get our calculated value to be like a 0.217? Wasn't it that one that was very small? Boom, there we go. Okay, so let's take this information right here. Let's go ahead and plug it in the calculator. Yes. This will be a 2x2. When you put in the dimensions, don't worry about the row or the column totals. Only the data itself. Okay, so we're going to help me remember these numbers here. Now I'm going to come on over here. We don't have to go to lists and spreadsheets like we've commonly been doing. Where do I go? Well, what do I do? Okay, definitely the scratch pad. Okay, so this button right here between 9 and catalog, I'm going to click it. And this time we actually do have a template for 2x2. But any other size matrix, you'll go ahead and use the 3x3. Okay. So I think it was 110, right? 106. 98. 98 and 86. Were those the values? Okay. So I always click tab, or you can just, arrow out of those little cells there. But once you got it in, now you want to arrow out of the matrix, so you have your cursor right at the end, and we need to store it as a letter. So I'm going to hit Control Variable, this button right here above 9. And what would you like me to use? X. Okay, X is fine. And whatever letter you want. Okay. I don't know. I've never tried. Try it and see. I don't know if it would say error.
Okay. Let's do dog. Okay. And I think
Yes.
and dog.
So much fun.
Did it work?
Yeah.
It did? Wow. Okay.
So I do Flutters' dog.
Now I got to tell you, just because of that, I want to do that too. Okay. Document B. All right, so let me put this in very quickly. I won't waste your time. Okay. All right. No, it's not. 110, what was it, 106, 98, and 86? Okay. All right, so now control variable J O K E R. And now let's see. J O K E R. That is cool. Okay. Nice. But again, whatever you guys want. Okay. Hey, there you go. Okay. So now I've got it saved in there. Now what? Now we go to menu. Statistics. But we want to go down to the bottom. Stat tests. And we want the two-way test. Remember, GOF is another chi-squared test, but that's what we call goodness of fit. Completely different. Okay, so we want the two-way test. The observed matrix, I will type in J-O-K-E-R. I can, but yeah. And there we go. And see, check it out. What did my chi-squared value come out to be? The 0.217. Here's my p-value. Okay. Now, what was it? We wanted our critical value to be what? Does anybody know what the critical value is in this case? What's my degrees of freedom? Okay, it's 1. Okay. And what, did this problem have us at a specific significance level? Did it say 1, 5, or 10? What would you guys like? 5. So let's say 5. So I'm going to go back over here to my notes. I need... Okay, so we're going to choose to go 5%, and we had a degree of freedom of 1. So it looks to me like we're going to have 3.84. Okay, so let me run over here real fast where I got this. Okay. Now remember, my calculated was 0.217. The critical value was 3.84, and that is definitely less than the critical. So what's happening? They're independent. So according to this, there's no relationship. Okay. Now, as far as the p-value goes, let's see if that's correct. So this is saying that there's independent, there's no relationship, right? Okay. So our value should be bigger than our 5%. Okay. What was our p-value? Let's come back over here. 0.641. Okay. So 0.641, is that greater than 0.05? Yes. So again, that's all the p-value is. It's just another way to determine if your original idea was correct or not. Okay. Now, there was also one other thing that you could do, because you could potentially be asked to go ahead and write some of the expected values. Does anybody remember how I bring up that matrix? Okay. So, yes. Okay. So, this same button I use to store it, I just won't push control, push your variable button. As soon as you do that, you're going to have a whole list, and you want EXP matrix. Okay. And as soon as you click enter, there you go. And if you go back in your notes, remember the one that we keep going to for our example, the expected frequency? That first column total times the first row total divided by 400, there's that 112.32. So everything is coming up exactly as we found by hand. Okay. How we doing? Yes, ma'am. Oh, sorry. We can. In fact, I think somewhere I do have instructions for that. The only thing is when it comes to the paper exam, you won't have anything like that. So for all of these different ideas, standard deviation, correlation, the mean of class intervals, you would just have to remember all the keystrokes. But about a month before we take the exams, by that time we should be done with our curriculum, everything we need, and we're just going to go back and start reviewing. We're going to take past tests, and we're going to do everything we need to. So did you want me to come up with keystrokes for that? Are we talking about like for a quiz or something?
No, just to like how you gave us the other ones.
Mm-hmm.
Just to, like,
Oh, just to have? Okay. I could probably get my hands on those. I'm pretty sure I do have some. I just have to find them. Okay. All right, so good. Spencer, did you have a question? Or Eli, sorry. You know what? It's Friday. Give me a break. Okay.
What was the equation to find I-squared and
Oh, the equation to find chi-squared? It was the sum of the square differences between the observed and the expected divided by the expected. And we actually had this close to the beginning. Right here.
Okay.
This guy.
So it's the
Now, this is if you wanted to go ahead and do it by hand.
yeah. So it's the observed minus expected.
And remember, you want the ones that are in the same cell. We can't, just randomly shuffle those up.
Oh, so you use
Hello?
as like the observed and the expected tables, just
Mhm.
as long as they're from the same cell.
Yeah, from the same cell.
Oh,
Like row 1, column 1. And the way we did it, the way I've done it on the homework is for the first 2, I am going to go ahead and have you work through those by hand. Okay. So you'd probably want to go ahead and create these columns that you can work through and easily get that information you want. So you need a observed column, expected column, the difference, square those differences, divide those squared differences by the expected value, and then take the sum, and that will give you the chi-squared. Okay. Oh, yes, sir. Just put it in the tray. Okay, thank you. So, all right. Questions? Okay, good. A lot of really good questions about that. Okay, so let me give you your assignment. Or do I have it over here? I think I got it over here. Yes. And I'm just going to go ahead and give you the rest of the period to go ahead and work on it. So I got 4 problems total. Okay. Oh, thank you. Oh, she is not here today. Hello, ma'am. Ma'am. You just delivered the pass? Okay, she's not here today. I'm sorry. Okay. So let's see here. There we go. All right. So let's say this will be due Monday. So you have the entire rest of the period. So that gives you about a good 25 minutes. Okay. You can work together. Okay. Help each other out. I'm going to go ahead and see if I can finish up the rest of those outlines. Did everybody who hasn't turned in their outline yet get it turned in? Okay. Now, everybody who did turn in your outline yesterday, I've read through all of them, and I wrote down, my thoughts. So hopefully that'll kind of help you as you move forward. If you haven't gotten that outline to me, just try to get it as soon as you can. Karime, if you would turn on that light, please. All right.